I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we'll discuss about the family of functions. I'll take up two examples to describe the family of functions. We'll have quadratic functions as a reference. As you know, graph of a quadratic function is a parabola. The first question here is describe the family of function. We need to sketch the graph of f of x equals to x plus 2 times x minus 4. Use your graph to sketch the graph of g of x, which is minus 2 times x plus 2 times x minus 4, and then sketch the graph of h of x, which is half of x plus 2 times x minus 4. So that is the type of question which we are going to look into. Now you can very clearly see that the very first function is f of x, which is given to us as x plus 2 times x minus 4. To sketch this graph, we need to find the x-intercepts. So x-intercepts are at which point? Can you tell me that? Well, to find the x-intercepts, we have to equate f of x to 0. So if f of x is equal to 0, that means x plus 2 can be 0. That gives you x as equals to minus 2. That is one of the x-intercepts. Or we could also have x minus 4 equals to 0, which will give us x equals to 4. So in this particular case, as you can see, we have two x-intercepts. To define the graph, we need the third point also. What could be the third point? Well, vertex is a good point to look into. So for this particular graph, the vertex will be right in the middle, right? So let's think about vertex of this graph. The axis is going to be midway between the two x-intercepts. So let's look into axis first. Axis will be at x equals 2, center point of the line joining the two x-intercepts. So we can add minus 2 and 4 and then divide by 2. So that gives us the value as 2 over 2, which is 1. So we have axis at 1. We can now calculate the value of the function at 1 to find the vertex. So we get this as 1 plus 2 times 1 minus 4, and this is equal to 3 times minus 3 or minus 9. So now we can easily sketch the graph. Well, some of you can also find the y-intercept, that is the value for x equals to 0. Y-intercept is going to be, when I substitute x equals to 0 in this equation, I get what? I get 0 plus 2 times 0 minus 4, which is equal to 2 times minus 4, which is minus 8. So now we have good points to sketch the graph. Let me make a rough sketch here on the side. So I'll make a smaller one and then share with you a much better graph. Okay. So we are looking at x-intercepts of minus 2 and 4. So let's say that is our y-axis. This is the x-axis. So the graph is opening upwards. We know that the y-intercept is minus 8 and the vertex is at 1 minus 9, correct? So I could roughly sketch the graph kind of like this. Is that okay? Where the critical points of our interest, which we just calculated, are these two x-intercepts, which are at minus 2 and 4. And we have this axis, which is at x equals to 1, right? And the vertex here is at minus 9. The x-intercept, the y-intercept is at minus 8, correct? So let me write down the vertex also, which is 1 minus 9. Does it make sense to you? So that is how you are going to get the graph of the function as shown here. Perfect. So that is the first graph. How do we sketch the second graph, which is minus 2 times f of x? Do you see that? So what you see here is basically, let me write it on the side. We have g of x, which is basically equal to minus 2 times f of x, correct? That means it is stretched and reflected. So instead of minus 9, the vertex will be now at minus 18. However, the x-intercepts will remain same, and the y-intercept will also be stretched and reflected. So what we now expect is a graph which will be kind of like this. You see that? Where this point vertex will remain at 1, but the y value will be plus 18, minus 2 times the earlier value. And the y-intercept will now be at 16. You get the idea. So that becomes the graph for g of x. The more important thing which you observe is that the x-intercepts remain exactly same. And that is what we say a family of a function. You get the idea. So when we are talking about a family of a function, then they have some common characteristics. In this particular case, the x-intercepts are common, and therefore we call it a family with common x-intercepts. So I hope you get this idea, right? Have a look at the visual to see how it works out. You can appreciate the family of curve in this particular figure. We have shown you the graph of the function x plus 2 times x minus 6. It is a parabola with x-intercepts at minus 2 and plus 6. The different graphs shown here have x-intercept at common points, and therefore they belong to this family with common x-intercepts. As we change the value of a, which is a vertical stretch factor, you can see how the graph compresses or stretches. It even reflects for negative value of a. However, all these graphs are going through two common points, which are the x-intercepts, and therefore we say that they belong to the family of quadratic functions with common x-intercepts. So I hope this is absolutely clear from this visual presentation. Let me now show you all the three graphs together in this particular diagram. So what we did was that we sketched the very first graph, which was shown here to you in blue. So this is f of x, x plus 2, x minus 4, which I had drawn earlier. So that becomes our function f of x. Now, if I have to reflect this particular function and multiply by 2, I get the function g of x, right? So this graph is g of x for us, where the point of the vertex is at 18. Important thing which we want to emphasize here is that the x-intercepts are still same, correct? Perfect. The third graph now, which we are looking into, is h of x. Now let's look into h of x. Earlier we had drawn g of x. So this is half of x plus 2 times x minus 4. That basically means it is half vertically stretched by a factor of half, or you can say compressed by a factor of half for the function f of x. Is that clear to you? So the function which has been compressed in this particular case with half the value will be what? So what we can do now, what we can do now is we can bring all the points half distance from the above, right? So the point which was at minus 9 will go to 0.5, and we have a curve which will go through these in a way like this. Do you see this? So the graph which I have now sketched is h of x, where the original graph has been compressed vertically by a factor of half. Is that clear to you? So we can actually get the functions from the main function, but what we observe once again is that the x-intercepts are common, and therefore we say it belongs to a family of functions where we have common x-intercepts. So I hope this is absolutely clear. Now let's look into another graph. We'll now sketch the graph with common vertex. So the question is to sketch the graph of f of x a times x minus 2 whole square minus 4, where the value of a is minus 2, 1 and half. So to sketch this graph, what will you do? Let me first sketch it. We have a vertex here which is given by the value 2 and minus 4. So that becomes the vertex for this particular graph. We can take a value of a as 1 to begin with. So if a equals to 1, in that case we have f of x as equal to x minus 2 whole square minus 4. We can find the value of y-intercept by plugging in 0 here. So we get 0 minus 2 whole square minus 4, which is 4 minus 4, and that is at the origin itself. So we have a parabola which I can sketch now as, let me just make a sketch here like this. It goes through the origin and the vertex is at 2 minus 4. Is that clear to you? So that becomes the graph of the function f of x. Now let us try to sketch the second function, which is g of x. Let a value be minus 2 times x minus 2 whole square minus 4. The vertex is same, so that is a common point. Let's find another point. Let's say what is the y-intercept. So if I substitute 0 here, I get minus 2 times minus 2 square minus 4, and that value is 4 times minus 2 is minus 8, and we have here minus 12. Do you see that part? Correct? So we have minus 12 this time at this value. So at the y-intercept is not at 0 now, but it is at minus 12. So when I do minus 2, so you get minus 2, that gives you 4. 4 times 2 is 8 with a negative sign, and then pulls 4 down. So we have a point which is right there, which is minus 12. Do you see that? Sorry, the y-intercept. So the y-intercept is at minus 12. The graph will be something like this. Important to note that the vertex remains common. You get the idea. So let me show you more accurate graph which I have drawn using a graphing calculator. So as you can see here, different graphs, all of them will have a common vertex. So this becomes a family of curve with common vertex. As you can see, different values of a, we could write different functions. For example, with g of x, we wrote minus 2, x minus 2 whole square minus 4. With 1, we already have a value. Let's say h of x is half of x minus 2 whole square minus 4. To sketch these graphs, you can find the y-intercepts and 2 more points, right? So let's say, we'll say find 3 more points. To sketch graph, we have a common vertex. Let me write down here. They have common vertex, which is at 2 minus 4. They all belong to this family with common vertex. As you can see from the graphs, if we reflect, it'll go downwards, and if it is stretched, it goes vertically up as shown here. Have a look at the presentation of these graphs. That will give you even much better idea of how it really looks like. So that is the family of quadratic functions with common vertex. In this visual presentation, which point do you think is common for all the graphs? Well, it is the vertex. And therefore, we can call this as a family of curves with common vertex. The vertex for each graph is at 2 minus 4. The value of a, the stretch factor, is changing, as you can see in the presentation. So that is the family of quadratic functions with common vertex. So I hope with this, the concept of family of curves is absolutely clear. So I hope with this you have understood the concept. Feel free to write your comments, share your views. If you like and subscribe to my videos, that would be great. Thanks for your time and all the best.